Today we're going over section 5.5, radical expressions with multiple terms, adding, subtracting, and multiplying. In this video, we'll go over problem number 2. We just discussed how to add and subtract when you have like radicals, but now we have to simplify some radicals first, like we learned how to do in a previous section. Let's look at number 2a. Is there anything I can simplify? Are there any perfect squares I can take out of the square root? Nope. So this one stays as root 6a. What about the second term? 54. Is there a perfect square I can take out? Yes. The square root of 9 times the square root of 6. 9 times 6 is 54, so the square root of 9 is what you can take out. That would be 3. So I have negative 4 times 3, and then what I have to keep under is root 6a. So this becomes minus 12 root 6a's. Then let's look at 216. What is the biggest perfect square I can take out of 216? And that would be 36. So this is negative 4 times the square root of 36. And what's left? 6a. The square root of 36 is 6, so this is negative 4 times 6, and then we have root 6a. 6 times 4, 4 times 6, negative 24 root 6a's. I can think about this as one piece, okay? I have 1 root 6a minus 12 root 6a's minus 24 root 6a's. What do students often forget, especially on the written exams? This is 1. Don't just get rid of it. So many people say the answer to this is negative 36 6 root 8. I got it. No, you didn't. This is something. Don't just disregard it. That is 1. So make sure you say 1 minus 12, which is negative 11, and then minus 24, which is negative 35. So the answer here would be, how many root 6a's do I have? Negative 35 root 6a's. Okay. Be careful about that. This is 1. If you thought about this like x's, x minus 12x minus 24x, that might clear it up for you in your mind. Let's try b. All right, I have the cube root of 2 and the cube root of 54. The first thing I want to do is simplify. What is 54? That's 27 times 2. So then I see that I can take the cube root of 27, which is 3. So this becomes 13 cube root of 2 minus 3 times the 3 here times the cube root of 2. Then I multiply 3 times 3, which is 9. So I have 13 cube root of 2's minus 9 cube root of 2's. And once again, if you say it like that and think about it like that, then you're just taking 13 minus 9. Okay, so try to keep that kind of clear in your mind. We're trying to simplify and combine like terms. So 13 minus 9 is 4, so I have 4 cube root of 2's, and that's your answer. Let's try C. How can I simplify with a 9th root? So this term has xy. There's nothing you can take out, but this term has x to the 10th. Remember, when you're simplifying, you can make 2 roots. Make sure you put the index of 9. And x to the 9th can come out, which would leave you just with x and y that has to stay in. X to the 9th, and then that 9th root undoes each other, and you're left with x. So this will give me x, and I have that 5 out front. So what do I have here? So I'll have 5x, and then the 9th root of xy, minus 4x, the 9th root of xy. When you're talking about like radicals, you have to have the same variables. If one of them had an x out front and one of them didn't, they are not like terms. Now, we don't care about the coefficient or that number in front, we don't care about, but we do care about the letters. So it's got to have all the same letters, okay? So I have 5x, 9th root of xy's, minus 4x, 9th root of xy's. So see, all the letters in that radical have to be the same thing. And then you combine the like terms. 5 minus 4 is 1. I just have 1 left, so I don't have to write the number 1. I just write x times the 9th root of xy, and then I'm done. Have so much fun with this puzzle. We'll see you next time.